All right. If you have a specific question, don't be afraid to jump in and ask the question. Yes, don't everybody speak at once here. So I'm just going to go ahead and get started with it. That way we're all on the same page here. So number one on the review. Travis collections of DVDs contain 14 comedies, 12 dramas, and 10 action movies. Find the following probabilities. So we have 14 comedies, 12 dramas, and 10 action. All right. So that's what we're looking at here. So for part A, or event A, I should say, it says randomly selecting 3 comedies without replacing between draws. So we're trying to find the probability of 3 comedies. Well, the first thing you need to do is figure out how many movies you have total. So you're going to add those up. You have 14 plus 12 plus 10, which gives you your 36. So having that total is very important. So when you're doing the probability of event A here, 3 comedies without replacement, you go to the comedy section, you go, okay, there's 14 comedies. Out of the 36. Without replacing means once you take a movie, you keep it. So that means your numbers should be going down. So if I draw and I grab a comedy the first time, I now don't have 14 comedies left. I have 13, along with only 35 to choose from. So each time you're going to be taking one away. So then the next draw would be 12 out of 34. And then here you would just multiply all 3 of these together using your calculator. And when you do that, you would get, after you simplify, remember, always simplify, you would get 13 out of 255. All right, so now that I've kind of walked through event A, let's look at event B. Randomly selecting 3 dramas, replacing between each draw. So what do you think this one would do? Anybody? So first ask, is this an independent or dependent event? So when you're asking yourself, is it independent and dependent? That's going to determine what we're doing here. Anybody? If you don't want to say it out loud, you could just type it in the chat as well. I can see that. Okay, so why do you say that? So we had independent, is what we had said. Why do we think it's independent? Anyone else want to help her out why we think it's? So what word is important in event B that helps us understand that? Do y'all think that replacing is the important word in that sentence? Anybody? Okay, so if you're replacing it, it's independent. So how would I set my probability up then? So remember, it says randomly selecting 3 dramas, replacing between each draw. So how would I set this up? So let's just look at one piece at a time here. How many dramas do we have, guys? There we go. So you're going to have the 12 out of 36 as if you do the first draw. So what would be your second draw? Now, so we had 11 over 35 said, but let me ask this. If we're replacing it, will that change it? What does replacing mean? So you put it back. So when you say replace, that means you're putting it back. So if I put it back, what's the chance of me drawing a drama the second time? Yes, 12 out of 36. Okay, now remember, we just said that it wouldn't be 11 out of 36 because we replaced it. So it goes back. So I go and pick it up and go, oh, that's a drama, and I put it back into the pile and re-choose again. What about the third draw? Yes. Very good. And as Coach Jones said, none of the numbers are going to change because nothing from the first draw changed. Exactly. All of them would have to be the same. So then here you would multiply these 3 together with your calculator and then get your answer. So then here, once you simplify, remember always simplify, you get 1 out of 27. Or yes, that's what you get before you simplify. So I'll put that down. So 1,728 over 46,656, which does reduce to 1 over 27. All right, so that's event B. So let's look at event C and walk through it. Randomly selecting 3 action movies without replacing between draws. Sorry, guys. So is this independent, dependent? And what is my keywords here that helps me set this up? Okay, so without replacement, dependent. So with that, what would be my first probability, my first draw? 10 out of 36. Very good. So what would the second draw be? 9 out of 35. Very good. So what would my third draw be? 8 out of 34. Very good. So then we're going to multiply those 3 together. And when you do that, you get 720 over 42,840. Remember, always simplify if you can to get 2 out of 119. Very good. So then the last one for here is event D. So if we read it, it says randomly selecting 3 movies that are not dramas, replacing between draws. So I'm going to ask again. It says independent, dependent, and what words are my key thing? Replacing independent. Very good. So we're getting the hang of it, is what it's looking like from this. So if that is the case, what would be my first draw? So 3 movies that are not dramas. 24 out of 36. Now let me ask, how did you get 24? Very good. You would add all the non-dramas. So when you add those together, which would be the comedies and the action movies, you do get the 24 out of 36. So what would the second draw be? 24 out of 36. What about the third draw? Yes, perfect. Because we are replacing, it means it's going to stay the same with that. So then here, we multiply these 3 together. And we're going to get 13,824 over 46,656. And when you reduce that, you get 8 out of 27. And that is number 1. And that's a good one to help us understand the difference between independent and dependent here. Any questions on this one before we move on? Okay. So I'm going to ask again, is there any specific one, or do you just want me to go to number 2 that you would like me to do next? $15. Okay. So I'm going to get a new whiteboard up here. So if you're looking at 15 here. All right. So a bag contains 8 red marbles and 3 blue marbles. So I have 8 red, 3 blue. I'll color coordinate it to make it make a little bit better sense. All right. You randomly pick a marble and then return it to the bag before picking another marble. So the first question here, I'm just going to say this, is it independent or dependent? So you randomly pick a marble, then return it to the bag before picking another marble. So is this independent or dependent? It is independent. So I can come over here and say independent. Okay, so that's going to help me. So why would it be independent? The return, the replacement. Very good. So little words make a big difference when you're going into this. So with that being said, we're trying to now find the probability of red. And what does that symbol that I just wrote mean? So, and. Okay, so red and blue. And when you have and, what do you do? Very good. We're going to multiply. So what is the probability of red? 8 out of 11. Very good. So if I have 8 out of 11, and, which means we're going to be multiplying, what's the probability of the blue if we are returning it? 3 out of 11. Very good. So you would multiply these together, and you're going to get 24 out of 121. And that is number 15. So always ask yourself, is it whether it's independent, dependent, if it's an independent, dependent versus mutually exclusive or inclusive. And then that's going to tell you how to set up the problem from there. And look for keywords. And remember that the answers on the test may be a fraction or decimal or percentage. So always read carefully how they want you to put it. What else do we got, guys? What's your next question? 16. Okay. So a box has green and apparently we've all agreed with 16. A box has green and red apples. 3 apples are drawn without replacement. The probability of selecting a red apple and then a green apple is 0.24. All right. New board. The probability of selecting a green apple in the first draw is 0.43. What is the probability of selecting a red apple in the second draw if the first apple drawn was green? All right, so with this information that we have here, so we know it's without replacement here. The probability, it says selecting a red apple and then a green. So the probability of red and green is going to be 0.24. The probability of selecting a green apple on the first try, so the probability of green is 0.43. And then the question is, what is the probability of selecting a red apple on the second draw if the first apple was drawn? So that's going to be written like so. So the probability of event A given B. So think of it this way. The probability of A and B, I'm going to write it out in words this time, over the probability of B. So you got to figure out which one is my and which is my given of this. So if you read it again, it says, what is the probability of selecting a red apple on the second draw if the first apple was green? So then here, just setting it up, the probability of red and green is 0.24. That's going to be my top or my numerator. And then if the green one was drawn first, would be that 0.43. Very good. So then here, all you got to do is divide those, guys. So 0.24 divided by 0.43, which gives you, does anyone know? .56 when you're rounding, or you could say 56%. But always be careful with how far they want you to go out with that. Very good. And that was number 16. I forgot to put the number over here. Are we okay with that one? Okay, good. What else we got, guys? $18. Okay. Start with 18 here. So with 18, It says, let me turn to it. Sorry, guys. In a neighborhood, 2/3 of the residents vote to plant daisies at the front entrance. 5/8 vote to plant daisies and daffodils. What fraction of those who vote for daisies also voted for daffodils? All right, sorry, can't speak today, guys. So I'm gonna write down my key information. So I have 2/3 daisies, plant daisies. And then we have 5/8 plant daisies and daffodils. If my pen will work, that'd be great. There we go. Okay. So I'm going to give you a minute. How do you think this should look? Anybody? So what would be the setup for this? This is very similar to what we just did with 16. So, and yeah, I would definitely do this with a calculator here. So you're going to have the 5/8 over 2/3. And then, like I said, use the calculator. Don't try to like overcomplicate this. So when you plug this in your calculator, what do you get? So 5/8 divided by 2/3. I didn't get 0.42. Let me try it again. I did get the 0.94. Very good. So when I plug that in, I get 0.94, or I could say 94%. So again, remember the setup is the probability of A given B would be the probability of A and B over the probability of B. So that would be your answer right there. Questions on this? And yes, remember to put the fractions in parentheses. What else we got, guys? That was 18 I just did. Oh, 8. I saw 8 and then 19. That's okay. I was like, wait, I just did 18. All right, so let's do 8 because I saw that one first. All right, so when you go to 8, have a good one too. It says you have, there are 5 nickels, 3 dimes, and 5 quarters in your pocket. So I'm going to write this information down. So I have 5 nickels, 3 dimes, and 5 quarters in your pocket. You randomly pick a coin, find the probability. I'm going to write that out. Nickel. And what does that symbol that I just drew mean? Or. Very good. So the first question you have to ask yourself is, Is this mutually exclusive or inclusive? So you randomly pick a coin. Would this be exclusive or inclusive? Why do you think it? All right, so I've had one of each one. So what is the big difference between inclusive and exclusive? Does anyone remember? All right, so why are you saying you switched your mind? So you're saying it's exclusive. So, but tell me why. That doesn't answer my why question. All right, so it is exclusive. Think of it this way. How many coins are we taking out of the pocket? We're taking one. And can you be in more than one of these categories? Can you be a nickel and a dime? No. So exclusive is when you're one or the other of this. So like left or right, nickel, dime, or quarter. So this is exclusive. Let me write that down. All right, so if it's mutually exclusive, find the probability of a nickel or a dime. So what's my probability of a nickel? 5 out of 13. Very good. Because remember, you have to add the numbers here to figure out how many coins you have in your pocket. So, or tells me I do what? What's my operation? We add. So I'm going to add. And then what's the probability of a dime? 3 out of 13. So I'm just going to add these across. 5 plus 3 is 8. My denominator is the same, so it's going to be 8 out of 13. Are we okay with that one? All right, very good. All right, so looking at the clock, that is my time. Well, I'm glad to see that that's a little bit easier. Don't forget, Miss Jones is going to be having hers at 1:30 today. So if you have any follow-up questions when you're working through this, don't forget to jump on it at that time. And then this one I've recorded, so I'll make sure I post this as well, okay? You're very welcome. I hope you all have a great day, guys. Let us know if you need anything. All right. Have a good one.